Good morning to one and all present here. I extend my warm welcome to our respect faculty members and my dear classmates. Today I will be presenting on the topic of plastics and rubbers in aerospace, which is a part of Unit 5 Aircraft Composites and Additive Manufacturing of the subject Aircraft Manufacturing Technology. So let's make a recall. What will be going to see? The main section is that what is the plastic and what are the applications, properties, advantages, and the challenges and the materials are faced in the aerospace industry. Okay, right? Topics for discussion. In this session, we will be exploring four major areas related to plastic and rubber in aerospace. The advantages of polymers in flight, key materials and types, essential aerospace applications, and the challenges, safety aspects with the future trends. These points will help us to understand why polymers have become such an important part of the modern aircraft design. So, what we are going to explore, which gives in this slide as an overview of the role of plastics and rubbers in aerospace. These materials are widely used because of the excellent strength to weight ratio, which leads to better fuel efficiency, improved overall aircraft performance, lightweight interior components, reduced manufacturing and maintenance components. Their flexibility in design also allows engineers to create complex shapes that would be difficult to achieve with metals. So the materials and types. Here we look at the different types of polymers used in the aerospace. Some important materials include thermoplastic, thermosetting plastic, and rubber materials. The thermoplastics like PEI and PTFE, the thermosetting plastic used in the interior panels, where the rubber materials such as silicone rubber and nitride rubber and fluorocarbon. So each material is selected based on the heat resistance, chemical resistance, durability, and weight requirements. And we see the applications in the real world of aerospace industry is plastic and rubber are used in almost every part of an aircraft. With some examples include that the cabin interiors, connectors, circuit housing, overheaded bins, rubber seals, O-rings, gaskets, fuel system components, and insulation panels for temperature and noise control. These ability to withstand extreme pressures and their resistance to chemicals make them ideal for aerospace use. So, future trends which develops in aerospace polymers focus on the improving flammability resistance, smoke and toxicity control for cabin safety, self-excusing materials, extreme environment durability for space missions, smart materials that can sense danger or temperature changes. These advancements aim to meet strict uh, safety standards while improving the aircraft performance and the passenger comfort. So, the flammability, it is a major concern where interior materials must pass strict test for low smoke and toxicity. The durability in the extreme environmental, such as very high or low temperature pressure variations and exposure to aircraft fluids. Internal damage in the polymer composite, such as delamination, can be invisible, making inspection more difficult compared to the metals. These challenges push engineers to constantly innovate safer and more reliability. The curiosity challenge, and this slide raises a question: why it is invisible internal damage in the composites more than dangerous than the external cracks in the metals? The reason is that the metal shows visible cracks on the surface, but the composites are layered materials where the cracks may be developed inside without any surface indication, which makes the detection harder and requires advanced inspection methods. So, next upon, when we take up the mind map, it shows that the polymers in the aerospace industry, which is combination of the plastics and rubber applications, it is a market significant and it also has some benefits in it. And whatever the points which are benefits, it also has the equal amount of challenges and limitations. So when compared, coming to the assessment question, So, the first question is which key property is the primary reason plastics and polymers composites are increasingly replacing metals in the large aircraft structures? The options are high electrical conductivity, resistance to UV light, excellent thermal insulation, and high strength to weight ratio. And the second question is, in aerospace interiors, what is the most critical regulators requirement driving the selection of the cabin plastics? The option is hardness, inflammability, and smoke emission, cost, and resistance. So here, when we come for question A, it's answers high strength to weight ratio because the plastic and the composites are replacing metals mainly because of their high strength to weight ratios. And the second question, it is the option of B, flammability and the smoke emission. In cabin interiors, flammability and smoke emission standards are most important safety features. And when we come across the reference slide, this slide lists the sources of use to prepare the content, including aerospace, polymers, research papers, and standards. So thank you for listening patiently. I hope this presentation gave you a more clear and understanding how plastic and rubber contribute to the aerospace engineering. I would happy to present this and thank you all.